All right, 1.6 is measures of spread. Specifically, we'll talk about variance and standard deviation. So first of all, a range is just our maximum value minus our minimum value. Our standard deviation is, this is not the mean. We're writing the wrong thing, guys. Standard deviation is the square root of the variance, which we'll get to in a second, slash the average distance away from the mean. The variance is the mean of the squared deviations from the mean, which just sounds like a bunch of, junk. But these measure data spread, okay? Which is basically just how far pieces of data are from the mean. So for this first example, we're going to find the standard deviation for the heights of the Dolphins, which are some sort of sports team, I'm assuming. So we have all our heights. So symbol-wise, this symbol, which looks like kind of a U with a thing on the front, or kind of like an M, we say it as mu, kind of like a cat, but like not meow, like mu. This is the mean of a population. So to find the mean here, you have to add up all of these heights. So 70 plus 71 plus 71 plus 73 plus 74 plus 75 plus 78 plus 79 plus 79 plus 80, and divide that by how many, which is 10. And I did that for you. If you add them up, you get 750 divided by 10 is 75. So now let's go to our table. To find our deviation here, our second column, you do 70 minus 75, which is negative 5. 71 minus 75, which is negative 4. Negative 4, and so on. So 73 minus 75 is negative 2. 74 minus 75 is negative 1. 75 minus 75 is 0. 78 minus 75 is 3. 79 minus 75 is 4. Again, 4. 80 minus 75 is 5. Okay? So if you add up all these distances from the mean, you end up with 0, because that's because of the negatives that are included. So the next thing we do is we square those deviations to get rid of, and deviations are just differences, okay? We square all those to get rid of the negatives. So negative 5 in parentheses squared is 25. Negative 4 squared, 16. There's another 16. Negative 2 squared is 4. 1, 0. 9, 4 squared is 16, 5 squared is 25. If we add those up, we get 128. And again, this is without the negative, so the number means a little something to us now, because it doesn't just cancel everything out, right? Okay, so now we are going to calculate the variance and the standard deviation. And essentially you need the variance to then take the square root of it to find the standard deviation. So our formula, so this is variance. I'm going to write it right here. You can see by that symbol. So that equals the sum of all the xi minus mu squared. Sorry, that should have been a mu. Okay? That just means add up all these squared differences, which we did, divided by our number, so divided by 10, because that's how many we have. We added all those up, we got 128. Divide by our 10, we get 12.8. And since our units are inches, because our height was in inches, we get 12.8 inches squared. So here's why the variance isn't that helpful. If you're talking about height, inches squared does not mean much, right? So to find the standard deviation, we'll take the square root of that, the square root of the variance, or the square root of 12.8, which is about 3.58. And when we take the square root of the inches squared, we get inches. And that's a lot more useful as far as heights. So what this means is on average, those values are about 3.58 inches away from the mean. So this formula we used, which is really this one for variance, and then you take the square root of it to find the standard deviation. We have an n on the bottom for population. So most of the time, we will actually be talking about samples. Mostly samples in this book, in this course. It's just a slightly different formula. So keep that in mind. So over time, mathematicians have realized that when you deal with a sample, you should divide by n minus 1 because it gets you better data. I'm not that type of mathematician. I couldn't tell you why, but we just go with it. And we use Roman letters instead of Greek. So for mean, it's x with a line above, which we say x bar. And for variance is s squared. And standard deviation is s. So easy to remember, s for standard deviation. And so the formulas are very much the same. So s squared or variance is the same, except we divide by n minus 1 instead, because, you know, statisticians told us to. And our s, our standard deviation, we divide by n minus 1, just like our variance. So I'll show you one of these. So we're talking about earthworms. Some person named Mr. Green dug 7 different holes and counted earthworms, which sounds gross. Like, I don't know, it seems like something like at least a younger daughter, Paige, might like doing, digging for worms, but we'd have to see. She always seems to play in the dirt a lot at school from, you know, the condition of her clothes when she comes home. But anyway, he found these counts as far as earthworms. And we want to calculate sample variance and sample standard deviation of the numbers of earthworms. The only thing that really changes is instead of dividing by n minus 1 at the end, we divide by n. That's really the only difference. So first we'll find the mean, which is our x bar. And so if we add up all these numbers here, we get 90. I went ahead and did it for you. You're welcome. So our x bar, or mean, is going to be 90 over 7, because there's 7 holes he dug, 7 numbers of earthworms, and this equals 12.86. And so then what we do, for this next column, you subtract 12.86 from every single one of these numbers, and this is fine to use your calculator on if you're doing it on your own, because it's a little bit tricky to do in your head, I think. Equals, 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 bunch of equal signs. And we end up with negative 8.86, 10.14, 2.14, and I have these written down. I would not be able to do this fast. Negative 2.86, negative 4.86, negative 0.86, and 5.14. And if you add these up, you get close to 0, but not exactly, but that's just due to the rounding we did. So as long as it's close to 0, you're all set. If we square all those, we get, and again, we're squaring negative 8.86, 10.14, etc., all the way down. So we'll get 78.5, 102.82, 4.58, 8.18, 23.62, 0.74, and 26.42. Take my word for it. If you want to check my work, you can. And if you add those up, you get 244.86. Okay. So now, we had our mean. Now to find our variance, which is now s squared, we can do that total here divided by not 7, but 7 minus 1. Okay, so that's our n minus 1, just because it's a sample. We're told to do a sample, so we use n minus 1. And so if you divide 244.86 by 6, you get 40.81. And since the deviations were squared, and we're talking about number of earthworms, this is really like worms squared, which depending on my mood kind of makes me giggle. But again, that doesn't mean much, like 40.81 worms squared. Okay, so that's why we use standard deviation. So our s, we just take the square root of our s squared, which is the square root of what we just did, and we get 6.39. We square root this, we get regular old worms. So what this means is on average, the number of worms was about 6 worms away from the mean.